Determine the values of h for which the following system is consistent. So as always, the first thing I'm going to do is convert the system to an augmented matrix for easier computation. So here we go. The first row of our system is going to be, again, just thinking about the coefficients. We're going to have 9h, and we'll use a dotted line here for our equals sign, and then we have 9. And the second row, again, just thinking about the coefficients, we have h1, -3. All right, so to determine the values of h for which the system is consistent, we need to row reduce our augmented matrix to its upper triangular form. So we are going to row reduce to, again, abbreviating upper triangular form. So we are going to start with the x sub 1 term in equation 1. And we want to use this to eliminate the entry below it. So how are we going to do this? Well, we're going to need to scale the first row by a factor of -h divided by 9, and then add this to the second row to attain the new and reduced second row. So here we go. The first row remains as it is. We have 9h, 9, with our dotted line for that equals sign. And so here we are with the second row, and again, or excuse me, the first row. Keep in mind that we're multiplying the entirety of the first row by that scalar -h by 9. So we need to distribute that through. And again, I'm writing it down every time, but you could do this in your head too. So here we go. We have -h plus h, which gives us 0. We're going to have -h squared divided by 9 plus 1, or 1 minus h squared divided by 9. And then last but not least, we're going to have -h minus 3. So -h minus 3. And again, we're delighted and excited because we see that we have attained that upper triangular form. So we're ready to start thinking about or solving for those values of h that may or may not make the system consistent. So we'll keep in mind that we know that the system is consistent as long as a contradiction is not produced. So the system is consistent when 1 minus h squared divided by 9 does not equal 0. So we'll use this to solve for h. So here we go. We have 1 minus h squared divided by 9 is equal to 0. And I'm not a fan of fractions, so I'm going to remove the fractions. I'm going to multiply both sides of the equation by 9 right off the bat to remove those fractions. So now we are left with 9 minus h squared is equal to 0, which is much more friendly. It's a difference of squares. We know that that's going to be 3 minus h multiplied by 3 plus h is equal to 0. And so we have two potential solutions. We have that h is equal to 3 and h is equal to -3. And now, as always, we want to exercise caution. We don't want to assume that these values of h produce a contradiction. We need to check. So we have two cases to check here. And again, we're going to plug these values into the second row. So again, we're checking 1 minus h squared divided by 9 times x sub 2. And we want to know, is that going to be equal to minus h minus 3? Ooh, how fun. We've got h's on both sides, so be extra careful. So case number 1. Let's think about what's going on when h is 3. So plugging this in, we'll have 1 minus 3 squared. So we have 9 divided by 9 multiplied by x squared. And we want to know, is that going to be equal to minus 3 minus 3? So of course we know that 9 divided by 9 goes to 1. So looking at the left-hand side here, we have 0 times x sub 2 is equal to negative 6, which in other words is saying 0 equals negative 6. No way! We know that this is a contradiction. So this is confirming to us that we need to exclude h equals 3. So we must exclude h equals 3 from the set of all reals because it produces a contradiction. So now let's go ahead and check what's going on when h is negative 3. And I'm always running out of room. So here we go, plugging h equals negative 3 into the second row. So we have 1 minus, so this is negative 3 squared. So again, we have 9 divided by 9 multiplied by x sub 2. And we are checking, is this going to be equal to minus a minus 3? Minus 3? So let's find out. So notice here, we already know what the left-hand side is going to be equal to. It's the same as case 1. We have 0 times x sub 2, and we want to know, is that equal to positive 3 minus 3? Which gives us 0 is equal to 0. And that's fine. This is a true statement. 0 is equal to 0. So this lets us know that therefore we can include x equals negative 3. Include h equals negative 3. So we need to exclude h equals 3 because it produced that contradiction. And we want to include h equals negative 3 because it produces a true statement. So we can say that therefore the system is consistent for all h the element of the real numbers except h equals 3. We have to exclude that value to produce a consistent system. And that's our beautiful final answer.